Hey all, Oliver here. This is another Skull Button Devlog. I'm talking about my game VSCS-III. This video is going to be kind of the second part of the one that I discussed last week, if I'm releasing this on time. Last week I was talking a bit about the main menu and the design of that, but in this one I'm going to be delving into the save system, which is, if it's not obvious by the name, is how the game actually saves persistent state. Because VSCS-III is obviously a game that takes many hours to complete, so I want to be able to give players, it sounds obvious, but I want to give players the opportunity to put the game down and then load it back up and then have it remember where they left off. As in, that's a fancy way of saying it actually writes files to your hard drive, which is fairly straightforward, but there's a bit of complexity in it that I think is worth talking about. So if the technical side of that, I'm not going to go too technical. I might show some code snippets on screen, but I won't be going, I'm not going to be writing code. I'm just going to be showing diagrams and stuff. But if that doesn't sound super interesting, you are welcome to skip ahead, because after that, I am going to show off the current settings window in the game. And I'm pretty proud of that. I'm pretty happy with how it's looking. And it saves 4 actually. It saves 4 user configurable settings and will actually save them to the disk. And they will persist when you close the game or load to the main menu. And I think that's pretty neat. Actually getting into it, I've got my little graphic as always here. This is kind of just to represent that if you're in save slot 1, we need to make sure that we synchronize 3 little things here. So you can pretend that this right here is the actual game and the gameplay. You can pretend that this right here is the actual data representation of that gameplay. For instance, what's loaded into RAM. And then the actual file on the hard drive, which I've set up, and with VSCS-II it was just a .vscs2 file, and for VSCS-III it's a .vscs3 file. This isn't actually a fancy file format, it's just a binary file, but you can give it a custom extension because it doesn't actually matter. It's just a binary file, I just like this. So that's what the save files look like. Okay, so another thing that I've been working on, and we'll see this in the engine a bit later, is I've been building out some widgets. So the one that you'll be seeing in these little diagrams I'm showing is the toggle. So it's pretty much as simple as it looks like this if it's turned off, in which case it has a value of false, it's a Boolean value. And if it's turned on, it looks like this, and then it has a true value. Pretty simple. There's also a configurable label. So for instance, what we're going to be talking about in this little example here is as if the player wanted to turn off post-processing effects in the game. And post-processing, for anybody who doesn't know, it's essentially just effects that layer over the game in post. So for VSCS-III and also for my last game, VSCS-II, what that looks like is a bit of like blur and also a bit of, I'm forgetting the words, a bit of a vignette around the game to make it look like it's kind of a bulging screen. And then there's also a blue tint, effectively. So all of that is done after the game is rendered, but that might be a little difficult for some people to look at. So in terms of accessibility, it's not great. So I've just decided to make it so that you can turn it on and off. And I did that in my last game as well. So good excuse to build a toggle there. But the interesting thing about that is you probably want to save when somebody makes a decision like that, because it's kind of frustrating if you turn off post-processing, because it's on by default because it looks really cool. But if you turn it off and you quit the game and you load back in and it's turned on again, you're going to go, oh, come on. So we want to remember that. Seems really obvious, and there's a lot more complex stuff that I'll be saving later on, but it's a really good starting point because it's just an on or off value, right? It's just this true-false toggle. So it makes for a really good example. Okay, brace yourself because I'm going to start showing some seemingly complex diagrams, and there's some complexity here, but it's simpler than it looks, so I'll walk you through it. So here's the problem that we're trying to solve here. When a player flips that toggle, obviously a pretty simple change, like we saw up here, is we can just change the visuals of that toggle, and we can have it know if the toggle itself is turned on or off, and that toggle is inside of the settings window. Essentially what these are just objects in the game or a location. So everything here is in the actual game. We'll focus on the right-hand side for now. And this is where the user is actually interacting with the game's state. But that game state, that post-processing value, whether it's turned on or off, the problem is we need to synchronize that in a few places. So when that toggle is pressed, we want it to reflect an actual game state, which is to say, we don't just want the toggle to flip because that's not what the player's expecting. They're expecting the toggle to flip, but they're also expecting that to have an impact on the game. That is to say, they want the game to look different. They want it to actually turn off or on the post-processing. So that's what I'm representing with game state in quotations. That is distinct from the actual data representation, which is on the left. So this is an actual object in memory. It's called save data, and I always have an instance of it, which is called current save data. If you don't know what that means or you're not a programmer, doesn't matter. All that's important is this is the literal toggle, this is the actual visuals of the game, and this is the data for the currently loaded save. You can think of it as your actual RAM, like your computer's short-term memory, effectively. And then on the left, we also have another place we need to synchronize this, which is your computer's long-term memory, effectively. So what's actually saved to the drive. So as I was mentioning before, what's saved to your hard drive is an actual binary file. And we need all of these to synchronize, but in a clever way, because there's a couple issues here. So for starters, if any of these fall out of sync with each other, the player is probably immediately confused. Maybe less so with the game save data, that might come later. But if they flip a toggle and then nothing actually happens, then these two have fallen out of sync. Or if the toggle doesn't actually reflect what's happening in the game state. Similarly, if you forget to save your game or the game doesn't save what you've done automatically, and then you load back up, that's effectively like a load operation is just taking this and overwriting it there. And a save operation is just doing that. So maybe that's a better way of putting it. But similarly, if those go out of sync, so you've flipped your toggle on and then you quit the game and you load back in and it's turned off again, that's essentially the left and right side of this diagram falling out of sync, which is not great. And another little wrinkle, that actual save and load operation, or that read-write operation, can be a bit expensive. It's not too bad. We're working with pretty small files here, but you don't want to be taking this game save data and writing it to memory 60 times a second. Like, you want to be smart about it. Again, this is not a massive game. We're not saving a ton of data, especially since the example here is just a Boolean value. It's just true or false. But, we want to just be conscious of that. It can add up very quickly. So what that usually looks like is you synchronize this with the hard drive when you quit the game or at specific save points. And then obviously you're just loading the game in, so that left to right synchronizes everything. And then when the game loads, you obviously want the toggle to reflect what's actually in the data, so there's a bit of complexity there. Okay, making sense so far? I hope so, because I can't actually hear whether you said yes or no. I'm assuming you said yes. Let's move on. All right, as mentioned, we flipped the toggle. What actually needs to change when the toggle is flipped? I kind of already went over this in the previous diagram, but that actual user input has to synchronize with the game state, as in post-processing needs to be turned on. Wow, very cool. The toggle has to visibly flip, but that's kind of a part of the actual user interface. And then we need to synchronize our save data. And then when the user quits the game, we write to the hard drive. Simple as that. Cool. So you can see how this is simultaneously pretty straightforward and also something that you might not consider if you're not a game developer or you're new to game development, or you're trying to build out a system, which is fairly complex. So in terms of actually building that system and what that looks like, this is the last complex flowchart diagram looking thing, I promise. So what we've got here, it kind of mirrors what we were looking at above. You can see we've got our actual game, and these blue rectangles here are objects in the game. as is this one, the save system, which is our special object. And then these files are just saves on your actual hard drive. So same as what we were looking at before. What we're doing now is we're just trying to architect a system to solve the problem that we were discussing. So how do you make sure that you are consistently doing this? Because we're not always just talking about the post-processing volume, which controls the post-processing, whether it's on or off, but we're talking about other things like a view controller or a file system, which is the simulated file system in the VSCS. So that might be a bit confusing. This is just a thing in code, don't worry. So what we do here, and the way that I've built out this system, let's focus on this part right here. So what I've done, I've got an object in my game scene called the save system object. It has a script attached that is called save system. There's only ever one of them. That save system always has a reference to the current save data, which if we go back up here, that's what this is right here. There's only ever one save loaded at a time. If it ever needs to save the game, it uses a save game operation, and it writes to one of these three files. Depends which one's loaded, either save 1, 2, 3. When the game needs to load, it calls load game, and it pulls one of those files up there. Same as what I was doing before. Now, while the game is actually running, we want to make sure that this current save data is up to date, so that when we call that when we call that save game operation, we're saving something that is actually current. And so we want this centralized location where we can modify the game's state. So when that toggle gets flipped, you can see that these arrows go both ways. So when the game actually loads, it goes and it flips that toggle. It goes, hey, this was turned on last time the game loaded, or the last time the game was saved. So set it to true. And then when the player goes, actually, I want to set that to false, so they turn it around. That's not actually what it looks like, but they turn that toggle around. It just does the operation in a different way. It does a set operation instead of a get. It goes and it sets that in the current. And you can see this is just ping-ponging back and forth. We flip the toggle, it goes, okay, I'm going to go change this post-processing volume, boop, boop. And then it also goes, and I'm going to update the current state, and then I'm going to quit the game, which is going to save the game, which is going to write to my save, and then I quit the game, I load back into the game, I go, okay, I was on save 1, I'm loading save 1, it goes, okay, save system, loads the game, loads in this file like so it's the current save, and then when the post-processing volume starts up, it goes, hey, am I supposed to be turned on? Oh, I am, because that's what this data says. Boop. And then when the settings window opens, it goes, hey, is this toggle supposed to be on? And then it goes and it grabs that value. Same thing, and it goes, oh, I am supposed to be turned on. So, boop, it's turned on. That is a lot of words to essentially say all of these are now synchronized, except for this part, which is slightly weird because it only gets synchronized at certain times. I hope that made sense. If you ignore the rest of this, it's kind of as simple as this. When the player is on the main menu and they decide to press continue on a save file, it loads the game. And when they go back to the main menu, it saves the game. Everything else that I have discussed in this video so far is completely invisible to the player, and it doesn't actually matter. All that actually matters to the player is this. Everything else just has to work. Okay, I think I covered everything. Let's jump over to the game and I'll show you the very cool settings window that I've set up. Alright, here we are in VSCS-III. I think in the last video I already had that fancy new settings icon with the wrench that I'm very happy with. So let's open up that settings window. You will see I still have that bug where it overlaps the taskbar. I will fix that eventually. Okay, but this settings window looks a lot different now. So you'll see that our select drop-downs, there's now one for theme. That was there before actually, but there's an additional one for the cursor selection. We've got our toggle, which I was just discussing, and I've also actually built out a radio button group. So there are radio buttons in here and they're in a group, so you can only select one or the other. So let's just go top to bottom. Theme selection, let's pretend I'm a player and I want to change all of these. So you'll know where this is going if you've been paying attention. Maybe I don't like the color green. It's me from an alternate universe, and I really like, what color? Maybe I like the ribbit theme. Oh, maybe I just don't like dark green. Maybe I like really, really bright, eye-burning green. So let's go with that. And then I want to change my cursor, and I'm going to change it to the one from VSCS-II, because I'm a big fan of VSCS-II. Also, shout out to my coworker, Hi. Thank you for letting me use your name for the mouse cursor that you use at work. I might change that, but that's a little Easter egg, maybe just for the vlogs. Actually, maybe I really like this, because as mentioned, I really like that disgusting bright green. But maybe I don't like blurry old operating systems, so I'm going to turn off post-processing, and I'm going to change the clock to 12-hour, and then I'm going to remember that I'm not actually American, and I'm going to change it back to 24-hour. Okay, very cool. You will also have noticed that while I'm doing that, changing the theme does actually change the theme of the toggle and the radio button display. So while I was doing my little skit there, you might have noticed that. I'm very happy with that. It's a lot of extra little sprites and extra little work, but it looks pretty good. I have also added a new theme called Sandstone that I'm very, very happy with. And here's what the inactive window looks like. So, pretty neat. Let's go back to Ribbit, because I'm pretending I like this bright, crazy look. And I've been playing VSCS-III. I've been having a really good time. And I'm done. A character in the game said something that made me mad. And I'm done with this. I'm quitting to the main menu. I quit the game. This button doesn't do anything because we're in the engine. But then I come back because I've realized this game actually rocks and I want to continue. And I open up my settings window and wait a second, it remembered my mouse. That's pretty cool. And there we go. It remembered everything. I also remember I actually wanted post-processing off, and then I get angry and I quit again. I continue and hey, everything's as I left it. I'm kind of beating a dead horse at this point, but the reason I'm so proud of this is because, as I mentioned previously in the diagrams that I was showing you, all of this is actually synchronizing live. So you'll notice that when I open the settings window, it's also remembering what mouse settings I'd picked. So each of these widgets is configured with a default state when this menu boots up. So when I open the settings window, it's grabbing all those values. So it's going, oh wait, what am I supposed to populate this theme with? What's the default value? And it goes, okay, it's supposed to be Ribbit. What cursor was selected? Oh, it was Mayfly OS, okay. Was post-processing on? What was the clock display? All of these little things. So it's a pretty good pattern, I think. I think it works pretty well. And then, obviously, it's saving that to the hard drive when I quit to the main menu. And it's just retrieving it from the hard drive when I load the game. And that's retrieving it from the current save data when I open up anything relevant to that data. Okay, I think that's just about everything. A lot of work has gone into this, and I'm very happy with it. And this window is going to get increasingly more complex as I keep on developing the game. One thing that I might do is split out diegetic versus non-diegetic settings. That's something I've been thinking about a lot, because if you were on an actual operating system, so if you were in universe using a VSCS-III, or a better example, if you're actually using a computer that runs Windows 3, you can't turn post-processing off. This is what it's going to look like, roughly. I need to tweak this. It's very blue. But, this is a game setting, but the theme, cursor, and clock display are kind of operating system settings. Like, these could feasibly exist in an operating system. Post-processing doesn't. So that is to say, theme, cursor, and clock display are diegetic. They exist within the universe. And post-processing is non-diegetic. Maybe that's only bugging me, maybe it won't bug actual players, but it would also just be nice to have a ton of settings, and then that way I can have a game settings menu that has post-processing, which, as I mentioned, is kind of an accessibility feature, and then also something else which I want to put in, which is like dyslexic-friendly fonts. I did that in VSCS-II, Maybe I'll put some footage up to give future me a little bit more work. But you can actually turn on a font that is a bit more readable in VSCS-II, and as you're probably looking at right now, it's obviously not diegetic. Like, the display would not be able to accept that, but it doesn't really matter because I'd rather have a good player experience than have, you know, everything be perfectly biblically accurate to Windows 3. Like, that's not the goal here. It only works when it actually serves a gameplay purpose. For instance, switching out cursors and actually using the correct colors. Also, last thing I will note, you will have noticed that one of the cursors is called Stray Pixel. See if you can spot the difference when I switch to Mayfly OS. And just in case you missed it, I will switch back to Stray Pixel. That is a reference, again, to Windows 3. The cursor we're actually looking at is kind of a adapted Windows Vista cursor. But on Windows 3, the initial mouse cursor for Windows 3.0 had this weird stray pixel. I'm referring to it as a stray pixel because it just doesn't really fit the design. And then I think it was in Windows 3.1 or 3.1 Workstation Edition or some other future revision of Windows 3, they removed the pixel, which is very funny to me. And also that cursor had a very rounded point. It had like a 2-pixel point. This is not important. There's a very good Posey video that I should also link in the description here if you're a mouse cursor nerd and you want to learn a little bit about mouse cursors. So I thought it would be funny to switch out the cursor with one that has a stray pixel, sort of in the same vein. I don't know if anybody's going to get that. Again, none of this is final, but I think it's a funny joke. I'm going to add a stray pixel to other mouse cursors, like I'm probably going to add or I've already designed weighting cursors for all of these, so like a little hourglass for each of these. For Luna OS, it was a little watch icon that shows up when the game is loading a new scene in VSCS-II. But there's no way for me to trigger that in the actual game, so you'll have to wait to see that. And there might be other contextual cursors. I'm still kind of figuring it out, but this is essentially swapping out a set of cursors is the point. So I think it would be very funny to have the stray pixel one just have a stray pixel on every single possible mouse sprite. There's just a random pixel kind of getting in the way, looking super ugly. I don't know. Little things like that I think make the experience a bit more fun. Maybe just for me, but maybe for someone else too. Who knows? Alright, I think I'm out of tangents, so I'm going to end the video there. Thank you for watching. I really appreciate it. Stay safe, stay warm, have a wonderful day. Bye.